Hey there. You ever just like stumble on something kind of niche, but then the more you learn, you just gotta know more?
I know the feeling.
It's me with thyroid carcinoma lately.
Really?
Yeah, not exactly a dinner party conversation starter, right?
Uh-huh, right.
But seriously, today we're diving deep, deep into the world of thyroid carcinoma, the main types, the causes, how it all works. And just to be clear, we're on a pure curiosity quest here, not medical advice, just trying to make sense of it all.
Exactly. Think of thyroid carcinoma as any cancer that starts in that little butterfly-shaped gland in your neck, the thyroid. It's actually not that common, only around 1.5% of cancers in the US. But here's the thing. It seems to like women more. Early on, in adulthood, I mean, but then later in life, it's equal between men and women.
Oh, that is interesting. So it's not just one disease then, right? We're talking like different flavors of thyroid carcinoma.
Absolutely. We've got four main types: papillary, follicular, then anaplastic, and medullary. Each one's got its own thing going on.
Okay, so like different models of the same car, but under the hood, totally different engines.
Perfect analogy.
So, all right, if we had to pick the most common one we're likely to run into, what would it be?
Hands down, papillary carcinoma. It's like 85% of all cases. And one thing that can really up your risks is being exposed to radiation, especially as a kid.
Okay, yeah, that's a little concerning, given how much we rely on x-rays and stuff these days. But there's this other thing about papillary carcinoma, something about how the cells actually look under the microscope.
Ah, you're talking about the orphan ani nuclei.
Yeah, that's it. What's that all about?
So it's actually a key identifier. The nucleus of the cell where the DNA hangs out, it has this distinct look. Helps pathologists know what they're dealing with.
Wild. So even something that small is a huge clue.
Okay.
Now, so we've got the common one. What about follicular carcinoma? Is that similar to papillary?
Not quite. It's less common, maybe 5 to 15% of cases, and tends to pop up more in areas with like iodine deficiency. The tricky thing is follicular can be tough to tell apart from the benign tumors, the harmless ones.
Oh, so it's like trying to spot a wolf in sheep's clothing.
Exactly. Got to be really careful with examination and testing to get the diagnosis right.
Sneaky. All right, so we've got common, we've got sneaky. What about the rarer ones, but potentially a bigger deal?
That's where anaplastic carcinoma rears its head. This one's in under 5% of cases, but it's known for being aggressive, really aggressive. Often develops from existing thyroid cancer, and because it grows so fast, spreads to nearby areas in the neck, can be quite serious.
Yikes. That sounds pretty intense compared to like the papillary carcinoma, which you said usually has a good prognosis.
Exactly. It really highlights why we got to be able to tell these types apart. Might all be thyroid cancer, but they don't play by the same rules.
True, true. Okay, last but not least, there was medullary carcinoma. What's the deal with that one?
Now, medullary is interesting because it comes from a different cell in the thyroid, the C cells, and those guys, their job is to produce a hormone called calcitonin.
Okay.
And that calcitonin, we can actually measure that in the blood because it's a way to help diagnose it.
So it's like medullary carcinoma comes with its own alarm system.
You could say that. And another thing, this one's linked to a genetic condition. MN syndrome stands for multiple endocrine neoplasia. Basically, it means you're at higher risk for tumors in a bunch of different glands, thyroid being one of them.
And that's where it gets really wild, right? Because the research mentioned something called prophylactic thyroidectomies. Basically, if you've got a family with a specific gene mutation, the RET mutation, linked to that MEN2 thing, they might actually recommend removing the whole thyroid, just as a precaution.
Drastic, sure, but it shows how much our genes can tell us. Knowing that risk factor can be huge.
Wow. Really makes you think about that whole nature versus nurture debate, huh? How much is baked into our DNA? And how much is the world around us?
And speaking of which, I think it's time we tackled the big question. What causes thyroid carcinoma in the first place?
Right. What is the culprit?
Like most cancers, it's not so simple. It's this mix of what you're born with and what you encounter in life. Think of it like baking a cake. Got to have the right ingredients, but the oven temperature matters too, right?
So let's break down those ingredients then, shall we? On the genetic side, what's going wrong in our cells to cause this?
Okay, so imagine your cells have these control panels, right? Regulating growth, division, making sure everything's running smoothly. When we talk genetics, we're talking about glitches in the blueprints for those panels, our DNA.
So like typos in the cell's instruction manual?
You got it. And even a tiny typo can change the whole meaning of a sentence, right? These mutations can really mess with how the control panel functions, can lead to cells growing out of control, which, hello, cancer.
Makes sense. So what are some of the specific typos and mutations linked to thyroid carcinoma?
Two biggies are the MAP kinase pathway and the PI3K AKT pathway. Those are important ones.
Catchy names. What do they do, though?
Think of them like the engine and steering wheel of the cell. Mess with either one, you're in for a bumpy ride.
Okay, so those are like the main players, but they can get messed up in different ways depending on the type of thyroid cancer we're talking about, right?
What?
Same car, different ways to crash it.
Now you're getting it. Each type often has its own set of genetic quirks, those typos we talked about. So, for example, papillary thyroid cancer, you see problems with genes like RET and BRAF. But follicular, that one's more about RAS and PIK3CA.
It's like each type of thyroid cancer has its own fingerprint.
Exactly. And those fingerprints, they're what make each subtype act differently, how aggressive they are, where they might spread, how well they'll respond to treatment. Crucial stuff.
So it's about figuring out the instructions for that specific type of cancer, then we can tailor the treatment, right?
Exactly. But it's not just about spotting the mutations on their own, it's how they work together, and importantly, how they interact with environmental factors, too. Remember that cake analogy?
Right. It's not all about the ingredients.
Yep.
So let's talk environment then. What are some of those external factors that can make thyroid carcinoma more likely?
Two big ones come to mind straight away: radiation exposure and iodine deficiency.
Let's start with radiation. We touched on it, but I'm curious to go deeper.
Makes sense. So ionizing radiation, especially during childhood, big risk factor for papillary thyroid cancer. Are you familiar with the Chernobyl disaster?
Likely, yeah.
Well, sadly, that led to a huge spike in thyroid cancer, especially in kids who were exposed. Shows you how important radiation safety is.
That's scary. Makes you rethink all those dental x-rays, huh?
It really does. Now, iodine deficiency might seem less dramatic, but it's no joke.
True. We learned about that back in school. Iodine deficiency can cause goiter, right? The enlarged thyroid. But how's that connected to cancer?
So your thyroid needs iodine to make hormones. Not enough iodine, your thyroid goes into overdrive trying to compensate. And that can make cell mutations and eventually cancer more likely, especially follicular thyroid cancer.
So the thyroid's working overtime, and eventually something's got to give.
Precisely. And what's fascinating is where you live and what you eat plays a role. Places with low iodine in the soil or diets low in it, they see more follicular thyroid cancer.
It really shows you how connected everything is, huh? Our environment, our food, our health.
Totally. And sometimes something as simple as making sure you're getting enough iodine, either from food or supplements, can make a real difference.
Okay, so we've covered the common type of thyroid carcinoma, the sneaky one, the aggressive one.
Yeah.
We've talked genes, we've talked environment.
Yeah.
Where do we go from here?
Well, now that we've got a handle on the what and the why, I'd say it's time to tackle the how. How do we diagnose this thing? What are doctors looking for? And what can we say about someone's outlook if they are diagnosed?
Those are the million-dollar questions, and ones I bet a lot of our listeners are wondering about.
So let's break it down type by type, because just like there are causes and those genetic fingerprints, how each type of thyroid carcinoma shows up and what we can expect, it's all different.
All right, so starting with the MVP, the most common one, papillary carcinoma, what should people be watching out for? Any red flags?
Often it starts with just feeling a lump or some swelling in the neck, usually right on the thyroid gland itself. Painless, usually.
So just feeling around your neck could be step one.
Well, it shouldn't be the only wild step. Just because you feel something doesn't mean it's cancer. Plenty of benign things can cause that. But it's definitely worth getting checked out.
So neck mass is like chapter one, but we need more of the story?
Exactly. That's where imaging and biopsies come in.
Right, the high-tech stuff.
So an ultrasound that can show us the thyroid, the nodule, give us an idea of its size, shape, any weird features.
It's like peeking inside without having to cut anything open.
Precisely. And if that looks sus, next step's usually a fine needle aspiration biopsy. Basically, we use a super thin needle, grab a few cells from the nodule, and take a look under the microscope.
Ah, so that's where those orphan Annie eye nuclei come in. The biopsy can tell us if it's cancer at all, and if so, which type we're dealing with.
You got it. And once we've got that diagnosis, then we can start talking treatment, which, surprise, surprise, depends on the type and how far along it is.
Okay, so let's stick with papillary for now. What's the usual game plan?
For most papillary thyroid cancers, we're talking surgery, taking out the thyroid, either part of it or the whole thing.
Whoa, okay, so what makes the difference there? Why take out some versus all of it?
Depends on a bunch of factors: how big the tumor is, where it's hanging out, if any lymph nodes are involved, the patient's own risk factors, all that.
So it's not like one size fits all.
Yeah.
It's about figuring out the specifics and tailoring the treatment.
You got it. And after surgery, some folks with papillary thyroid cancer, they might also do radioactive iodine therapy, help zap any leftover cancer cells that might be hiding out.
So it's like sending in the microscopic cleaning crew to make sure they got everything.
I like that. And the good news is, papillary thyroid cancer, it tends to respond really well to treatment. Most patients do great long term.
That's good to hear, at least. Okay, what about follicular? How's that one treated differently?
So similar to papillary, surgery is usually the first step, but follicular, it's got more of a taste for the bloodstream, so even for smaller tumors, we often recommend radioactive iodine therapy afterwards just to be safe.
Gotcha, got to stay one step ahead. So with both of those, papillary and follicular, you're saying long-term monitoring is key.
Oh, absolutely. Regular checkups, blood tests, sometimes scans. It's all about catching any signs of a comeback early on.
Makes sense. Okay, now, anaplastic. Given how aggressive that one is, I'm guessing the treatment options are more limited.
Yeah, you're right. Anaplastic, because it's often caught later, after it's already spread, surgery alone often isn't enough.
So what do you do?
We usually end up combining treatments, surgery, radiation, chemo, sometimes all of the above. The goal becomes more about slowing it down, easing symptoms, improving quality of life.
Fighting a war on multiple fronts. Okay, and finally, medullary. How's that one handled differently?
Medullary can be a bit of a curveball, mainly because of that MEN2 connection, that genetic condition. So yeah, we're treating the cancer, but we also got to think about those other glands, make sure things are okay there too.
Double the trouble.
Pretty much. But on the plus side, if we catch MEN2 early through genetic testing, sometimes we can actually prevent medullary thyroid cancer entirely. That's where prophylactic thyroidectomy comes in.
Wow, that's pretty amazing when you think about it. Using genetics to prevent cancer before it even starts.
It's a whole new world out there, and it's evolving all the time.
No kidding. This deep dive has been eye-opening so far. We've gone from these tiny little orphan annii nuclei to the big picture stuff like genes and the environment, and now we're talking about treatment.
And we're not done yet.
True. Next time, we're going to dive even deeper into the specifics of diagnosis and treatment for each type of thyroid carcinoma. We'll unpack what doctors are looking for, how these cancers are treated, and what the long-term outlook is. So listeners, keep those brains engaged because we're about to go even further down the rabbit hole.
It really makes you realize how much we still don't know, right? It's like we've only just scratched the surface of this whole thyroid carcinoma thing.
Absolutely. It's like we've zoomed in from a satellite view of a forest to like walking among the trees, each one with its own little story to tell. We've covered a lot of ground already, from those orphan annii nuclei and papillary carcinoma to how our genes and environment team up to cause all this. But I'm curious, from what we've learned so far, what surprised you the most?
You know, for me, it's that iodine connection. I mean, everyone knows radiation's bad, but the fact that just not getting enough iodine can like really increase your risk of follicular thyroid cancer, that's kind of wild.
It really is. It's like this hidden factor. Makes you wonder what else is out there that we haven't even discovered yet, you know?
Totally. And it highlights how much more research we need to do. But speaking of research, how about we circle back to those genetic pathways for a sec? We talked about the MAP kinase pathway and the PI3K/AKT pathway, but for our listeners who aren't like cell biologists, how would you explain what those pathways actually do?
Okay, so imagine your cells have these super complicated control panels, right? Like the cockpit of an airplane with all these levers and buttons that control everything. These pathways, they're like the master switches for growth and division. They make sure the cell is like multiplying at the right speed and at the right time.
Love the analogy. And if one of those switches gets stuck or breaks...
Chaos.
Exactly.
Yeah.
And that's what mutations do. They mess with those switches, and suddenly the cell's not following the rules anymore. It's growing out of control.
And that's when you get a tumor.
Right. Bingo. And just like there are different ways to break a switch, there are different ways those pathways can get messed up. Some mutations might make the pathway way too active. It's like the gas pedal is stuck to the floor.
And other mutations might just shut the whole thing down.
Really. Exactly. It's like cutting the brakes. Either way, it's bad news for the cell.
So basically, it's all about keeping those cellular switches working properly.
Exactly. And the more we learn about how those pathways work and what can go wrong, the better we'll be able to develop new treatments.
Okay, so it's like once we understand the problem, we can start looking for solutions.
Exactly. And it's not just about treating existing cancers. It's about identifying people who might be at higher risk in the first place.
Right, like with those prophylactic thyroidectomies we talked about. If someone has certain gene mutations, like that RET mutation linked to MEN2, they might choose to have their thyroid removed entirely, even if they don't have cancer yet.
It sounds extreme, but it can be life-saving. It's all about weighing the risks and benefits.
For sure. But it's amazing that we can even do that now, right? Look at someone's genes and say, hey, you might be at higher risk for this type of cancer.
It's incredible. Genetics is changing everything about how we approach medicine, but it's important to remember that it's not the whole story. Our environment, our lifestyle choices, those things matter too.
Totally. It's like our genes might provide the blueprint, but we have some say in how that blueprint gets built.
Exactly. It's a team effort between our genes and our environment.
I like that. We're not just passive bystanders. We have some agency over our health.
100%.
Well, we've covered a lot of ground again today, haven't we? From the nitty-gritty of cellular pathways to the big picture of genetics and environment. It's been quite a ride.
Tell me about it. But we're not done yet.
Nope. Next episode, we're shifting gears from the causes of thyroid carcinoma to how it's diagnosed, how it's treated, what to expect if you're diagnosed with it.
It's a practical stuff.
Exactly. So stay tuned, listeners, because we're about to get into the nitty-gritty of how this whole thyroid carcinoma thing plays out in the real world. All right, deep divers, buckle up because we're in the home stretch. We've spent the last 2 episodes exploring the what and the why of thyroid carcinoma. Now it's time to tackle the how. How do we actually diagnose and treat this thing?
The million-dollar question, right? And as we've seen, there's no easy answer. Thyroid carcinoma, it's not a one-size-fits-all kind of deal.
Not at all. So let's pretend we're doctors for a minute. What are the red flags, the clues that would make you think, this could be thyroid carcinoma? We need to investigate.
Well, more often than not, it starts with the patient feeling something in their neck, a lump, some swelling, usually right around where the thyroid gland is.
So step 1 is like a good old-fashioned self-check.
It's a start, but don't jump to conclusions just yet.
Yeah.
Lots of things can cause those lumps, and most of them are totally harmless. But yeah, if you feel something off, definitely get it checked out. Don't mess around with your thyroid.
Better safe than sorry, right?
Exactly. But feeling a lump, that's just the beginning of the story. We need more information, which is where imaging tests and biopsies come in.
The fancy medical stuff.
So an ultrasound, for example, can show us the thyroid gland in detail, let us see the size and shape of that nodule, and pick up on any suspicious features.
It's like getting a sneak peek inside without having to go full-on surgery, right?
Exactly. And if the ultrasound raises any red flags, well, that's where the biopsy comes in.
Okay, walk us through that. How does a biopsy work?
So there's this procedure called fine needle aspiration biopsy. Sounds scarier than it is. Basically, we use a really thin needle to take a tiny sample of cells from the nodule. Then we send those cells off to the lab to be examined under a microscope.
And that's where those orphan nuclei we talked about come in handy, right?
Bingo. The biopsy can tell us if it's cancer, and if so, which type of thyroid carcinoma we're dealing with. And once we know that, we can start talking treatment.
Right, because as we've established, each type is its own unique beast.
100%. So let's start with the most common one, papillary carcinoma. What's the usual game plan there?
Hit me with it.
Surgery. Most of the time, we're talking about removing the thyroid gland either partially or completely.
Okay, so what determines whether you take out some or all of it?
That depends on a bunch of factors. How big is the tumor? Where exactly is it? Are the lymph nodes involved? What are the patient's individual risk factors? We take all of that into account.
So it's about tailoring the treatment to that specific patient and their specific tumor.
Nailed it. And in some cases, after surgery for papillary thyroid cancer, we might recommend something called radioactive iodine therapy. It's basically like sending in a microscopic seek and destroy team to mop up any remaining cancer cells that might be hiding out.
Smart. Love it when we can outsmart those sneaky cancer cells.
Me too. And the good news is, papillary thyroid cancer tends to be very treatable. Most patients go on to live long, healthy lives.
That's definitely reassuring. Okay, so what about follicular thyroid cancer? How does treatment differ for that one?
Similar to papillary carcinoma, surgery is usually the first line of defense. But because follicular thyroid cancer has a bit of a reputation for spreading through the bloodstream, we're more likely to recommend radioactive iodine therapy after surgery, even for smaller tumors.
So a slightly more aggressive approach to match the cancer's more aggressive nature.
Exactly. And for both papillary and follicular thyroid cancer, long-term monitoring is key. We're talking regular checkups, blood tests, sometimes imaging scans, all to catch any signs of a recurrence early on.
Stay vigilant, stay ahead of the game. Makes sense. Okay, now for the big, scary one, anaplastic thyroid cancer. Given how quickly it spreads, are there even effective treatments?
That's where things get trickier. Because anaplastic thyroid cancer is often diagnosed at a later stage, after it's already spread beyond the thyroid, surgery alone often isn't enough.
So what's the game plan then?
We usually end up throwing the whole kitchen sink at it, combining surgery, radiation therapy, and chemotherapy. It's about slowing the cancer's growth as much as possible, managing the symptoms, and focusing on maintaining the patient's quality of life.
Fighting a war on multiple fronts. Okay, and finally, medullary thyroid cancer. How does treatment for that one differ?
Medullary thyroid cancer can be a bit of a curveball, mostly because of that genetic link we talked about, MEN2. So on top of treating the cancer itself, we've got to consider the potential impact on other endocrine glands as well.
It's like a 2-for-1 deal, but not in a good way.
Tell me about it. But here's the silver lining. If we can catch MEN2 early through genetic testing, we might be able to prevent medullary thyroid cancer entirely by removing the thyroid prophylactically.
There it is again, the power of genetic testing. Being able to intervene before cancer even has a chance to develop, that's huge.
It's game-changing, for sure.
No kidding. Well, we've covered a ton of ground in this deep dive, haven't we? From those microscopic orphan Annie nuclei to the complexities of diagnosis and treatment, it's been a wild ride.
Absolutely. We've explored the different types of thyroid carcinoma, unpacked the roles of genetics and the environment, and even delved into the ever-evolving world of treatment options.
It's been eye-opening for sure, and I hope our listeners are walking away feeling empowered and informed.
Knowledge is power. The more you understand about your health, the better equipped you are to advocate for yourself and make informed decisions.
Couldn't agree more. So, to all our deep divers out there, stay curious, keep asking questions, and never underestimate the power of knowledge when it comes to your health. Until next time.